welcome to exercise application video number 15. Today was a back and bicep day, which I know it's kind of boring because most of my workouts have like the same 3 workouts every week, but just bear with me. So today I did some lat pull downs, I did some lower back extensions, I did some straight bar pull downs, some bent over rows, and then I did some curl variations for the biceps. But today what I want to talk about is our equations for cardiac output. So I talked about in my last video the electrical current throughout the heart, and I hit on the sinoatrial node and how it is innervated by both the parasympathetic and the sympathetic branch of the autonomic nervous system. So today I'm going to expand upon that idea. So our formula for cardiac output is CO, or Q, is equal to heart rate times stroke volume. So think of our heart rate as something that has limits, right? So we will die if our heart rate is not within a certain range. So we can only manipulate our heart rate so much, but we do that via parasympathetic, sympathetic nervous system. So if it's parasympathetic, I've said this, it is inhibitory, we're sending IPSPs, we're releasing acetylcholine. If it is sympathetic, it is an EPSP, we're sending norepinephrine, we're sending epinephrine, we're increasing that heart rate. So today when I was working out, because I was using my sympathetic nervous system, I was exercising, getting blood flowing, trying to produce more force, my accelerator nerve was sending norepinephrine and epinephrine, and so in that equation, my heart rate is increased. And this is a positive correlation with my cardiac output. If my heart rate is increasing, my cardiac output is increasing. It's a one-to-one relationship, not necessarily positive, because if my heart rate's decreasing, my cardiac output is decreasing. The other factor is your stroke volume. So your stroke volume is how much blood your heart is actually able to pump out in one QRS complex, which we talked about with the EKG waves. And so there are 3 things that can affect that. Preload is one thing, which is the amount your left ventricle is going to fill right before it goes into systole. So the greater the stretch, the more contraction you're going to have. This is called the Frank-Starling mechanism. If you think, this is hard to do with one hand, but if you think of your actin and myosin, the more they're stretched apart, the more power and force you're going to have to contract them together. And so that is where we get that idea from. We have something called contractility. So if you have more sarcomeres, epinephrine, norepinephrine, you're going to have greater contraction of force. So your stroke volume is going to increase. And if your stroke volume is increasing, your cardiac output is decreasing, because again, it's heart rate times stroke volume. So mathematically, 2 times 2, let's say, we're calling 2 times 3, we're calling 3 the stroke volume is going to equal 6. If you make that stroke volume 4, you get 8. If you increase that, you get a greater cardiac output. And finally, we see our afterload, which if this increases, decreases our stroke volume. Our afterload is the amount of back pressure on our aorta. So if we have lots of pressure pushing down on the outside of our aortic valve, it's going to be harder for that left ventricle to pump blood out through the aorta. And if that increases, stroke volume decreases, and thus our overall cardiac output. So during exercise, we have increased venous return, so we see that our stroke volume increases as we get more blood flowing through to the ventricles, so we get a greater stretch, we get greater contractility because we're releasing epinephrine and norepinephrine. And since we're using so much of our blood through circulation because our body needs it, we have less that's going to be backflow in the aorta. So exercise physiologically functions to increase our stroke volume and both our heart rate, so that we have greater venous return and more blood pumping through our body, because we want more oxygen pumping through our body, which ties back into bioenergetics, because we want that